So this video is going to be a combination of Learning Target 15 and Learning Target 16 because they're very closely related, and you'll generally see a question on Learning Target 16 sort of relies on your work for Learning Target 15. So I'm going to sort of combine these two videos and do like one Learning Target 15 and then Learning Target 16 that goes along with that. So Learning Target 15 says I can model die and spinner sample spaces with polynomial expansions. So in this problem here, we have a spinner that has 5 wedges of equal areas. The wedges are labeled with the numbers 1, 2, 3, 3, and 8, as shown below. We spin the spinner 4 times and add the results. The question is to write a polynomial power that represents this situation. So to write our polynomial power, we're going to have a polynomial, so a bunch of stuff of the form x to some exponent all added up together. And then the part that says power means that that entire polynomial is going to be raised to some power. So let's just sort of remember how we model these types of situations. So in our polynomial, we're going to have x raised to different exponents, and those are going to all be added up. The exponents are going to represent each of the possible outcomes in our situation, each of the possible spins that we could get. So we're going to have x to the first plus x squared plus x cubed plus x cubed plus x to the 8th. So what we're doing is our exponents on the x's within the actual polynomial, those represent the different possible outcomes that you can get. Now you could instead, if you wanted to, write this as x to the first plus x squared plus 2x cubed plus x to the 8th, right? Because you could combine these two terms together. You won't always have terms within your polynomial power that you can combine. But in this case, you have 2 different wedges that are labeled x cubed, so you can just combine those and write them as 2x cubed. Now, we need to think about the power part of this. So we're going to raise this polynomial to a particular power, and the power that we raise it to is going to be dictated by how many times we spin the spinner, or how many times we roll the die, or how many times we do the experiment and add them up. So in this case, we spin the spinner 4 times, so the power that we're going to put on this is a 4. So the exponents on the x's inside of our polynomial, those are going to be the different possible outcomes from a single spin. The power on the entire exponent, that's dictated by how many times do we spin the spinner before we add up the results. So either of these two answers is perfectly fine. So now let's look at Learning Target 16. So Learning Target 16 says I can interpret Wolfram alpha output from a polynomial expansion to discuss the probability of an outcome. So in the last problem, we came up with a polynomial power to represent that spinner situation. The idea is that if you actually multiply out that polynomial power, it gives you more information about the situation. So we usually use this computing software, Wolfram Alpha, to do some crazy math that would take us way too long to do by hand. So if you took your answer to the previous question and plugged it into Wolfram Alpha, you would get this polynomial. Now, when you get this polynomial, the exponents represent what are the possible sums you can get from having multiplied that spinner 4 times and added up the results. So if you had taken that spinner on the previous question, spun it 4 times, added up the results, the 32, the 27, the 26, the 25, the 22, and so on, those would be the possible sums that you could get from doing that experiment. The coefficients, or the numbers out in front, that tells you how many different ways can you get each sum. So for example, there are 56 different ways of getting a sum of 10 from spinning that spinner 4 times and adding the results. Or there are 14 different ways of getting a sum of 6 from having spun that spinner 4 times and adding the results. There are 30 different ways of getting a sum of 20. There are 4 different ways of getting a sum of 25, and so on. So this can help us to answer questions about the probabilities that you get different sums. So in part A, it asks you to find the probability that you get a sum of 9. So to find a probability, we want to think about, well, what are the number of ways we can get a 9 divided by the total possible outcomes. So for example, if there were 10 possible outcomes and 5 ways of getting a 9, your probability would be 5 out of 10, or 1/2. So to find this probability, we need to think about, well, what are the number of ways we get a 9, and divide that by what are the total number of possible outcomes, like different possible outcomes, like you could get a 25 or you could get a 22, so the total number of possible outcomes from this experiment. So to figure out the number of ways we get a 9, well, we can look at the coefficient of the x to the 9th term. So there are 56 different ways of getting a sum of 9 from having spun that spinner 4 times. So we next have to think about, well, what are the total possible outcomes? Now, to figure that out, that requires a bit of math. So what we're going to have to do is actually add up all the coefficients in this polynomial. And here's the reason why. So there's one way of getting a 32, and there's 8 ways of getting a 27. So far we have 9 different outcomes. One way of getting a 32 and 8 ways of getting a 27. But then there's 4 ways of getting a 26. So far we have 1 plus 8 plus 4 different outcomes. Well, then there are also 4 different ways of getting a 25. So far there are 1 plus 8 plus 4 plus 4 different possible outcomes. So what you have to do is add up all the different coefficients in order to figure out, well, what are the total number of possible outcomes. So this is going to take me a minute to add up. So I'm going to do 1 plus 8 plus 4 plus 4 plus 24 plus 24 plus 30 plus 12 plus 6 plus 32 plus 48 plus 72 plus 52 plus 36 plus 28 plus 36 plus 56 plus 56 plus 49 plus 28 plus 14 plus 4 plus 1. And I got 625. So there's 625 different possible outcomes that you can get from spinning that spinner 4 times and adding the results. So there are 625 total possible outcomes. 56 of them give you a 9. So the probability that you get a sum of 9 is 56 out of 625. Now, problem B asks us to find the probability you get a sum of 28. So once again, we're going to have a fraction. The top will be the number of ways we get a 28, and the bottom will be the total possible outcomes. We already know there are 625 possible outcomes, so we just have to figure out the top. So to figure out the top, what we're going to do is we're going to look in our polynomial up here. We're going to look for the term that has a 28 as the exponent, and the coefficient of that term will give us the number of different ways you get a 28. But if you notice, there is no x to the 28th term. What that means is that the coefficient in front of x to the 28 is actually a 0. That's why it doesn't appear. So there are 0 ways of getting a 28. Therefore, the probability that we get a sum of 28 is actually just going to be 0. Because 0 divided by anything is just 0. So in these problems, what we want to do is look at our expanded polynomial The exponents tell us the different possible sums, the coefficients tell us the number of ways of getting those sums, so there are a bunch of different probability kinds of questions that we could ask using that information.